We're going to be doing surface area again. We're only doing surface area, no volume yet. We're going to do pyramids and cones. This is the third section of the last unit of this class. Okay? 11.3. Let's get started. All right. A pyramid is a polyhedra that meets two criteria. You ready? It's got one base, and that base is a polygon. It is not a circle. It's a polygon. The other one is the lateral faces must be triangles that come up to a common vertex. I'm going to put those in front of you now. If you have your shapes, we have a pyramid here and here, two pyramids. Okay, this is going to be similar to it. We'll put it with it. Okay, all right. The faces will be triangles, and they'll all come to a common point. Here it is. There's some vocabulary that goes with it. We have a base. This particular one is like a square or a rectangle. We have another one, and we have the lateral faces, and those lateral faces are all triangles. You have notes on that. You can write these down, and as we go, I'll go back one more. Do you have your note sheet, Amy? There you go. And so I have it for you. We have the base. This is the bottom. You can, you know how we did last time? Wrote it down. Okay.
No, nothing's wrong.
Okay, good, good. We have lateral faces. You can put arrows to that. Lateral faces, those are the triangles. We have lateral edges, the base edges, and we have the height. Your height will be perpendicular to the base, and it will go up to that top vertex up there, that common vertex. We have something really important. It's the slant height. The slant height, and it is it's the height of one of those triangles. It's the height of the triangle, okay? It's perpendicular to the base of the triangle, the lateral base. It's called the slant height. There are two different kind of heights, a slant height and a height, okay?
I'm not able to read that, but that's okay.
We have regular pyramids. Just go ahead and just watch this. A regular pyramid has a regular base. Not all of our pyramids will be regular. We have a height that meets at the center. That's going to be pretty important, though. Actually, I think ours will be. I think all of ours will be regular because we're going to use 1/2 the apothem times perimeter, and so they will be regular. And the heights will meet at the center. For example, the height's going to be right down in the center. That would mean that this distance here is half of this distance out here, okay? Again, this distance here will be congruent to the distance out there, okay? Here's your formula. You've used this before. I suggest that you write this down again because we are going to translate what each of those letters mean. We have S equals capital B plus 1/2 P, and I've made a cursive L for you. Your B is just like the B we had, the capital B before, is area of the base. P is just like before, which is the perimeter of the base, but L is the new one. It's not a height, it's the slant height. It's the slant height.
So L is the only thing that's different.
Yes. The other two are the same as they were before.
So the only thing I'm going to write down is L.
Okay, that works for me. Your cone is very similar. A cone has a circular base instead of a polygon, and it's got a vertex that is not in the same plane as its base. It's somewhere above or below, and that comes to a point. The surface area is pi r squared plus pi rl. The r is the radius. The L is the slant height like we had before. Here's a picture.
Is that one for the cone?
Yes.
Wait a minute.
Wait, you said L is the slant height?
L is, yes.
So that's the height. Is that the height or the slant height?
Here we go. Let's look at it. Here's your base. It's a circular base. Here's our radius. You're going to need that for R. And here's your slant height right there for L. Okay?
Is that a 30-60-90 prime?
It could be a 30-69, yeah, and your particular problems won't need it, but if they gave you the height and the radius, you could find the slant height using the Pythagorean theorem.
Hey, Miss Carrie.
Yes, ma'am. All right, let's do some examples. We're going to do numbers 1 through 4 and 13. Yes, find the surface of each figure. Round your answers to the nearest hundredth if necessary. Leave your answers in terms of pi if the answer contains pi. This one does not contain pi. It's not a circle. What is the base of this one? What shape is the base of this one?
Triangle.
It's a triangle. What's the formula? I'm suggesting that you write the formula every time. B plus 1/2 PL. We only have one base. What kind of formula goes for this base?
A plus 1/2 base times height.
Yes. So it's 1/2 base times height.
Lowercase.
Yes. Plus 1/2 PL. Okay. What's the base of this triangle?
9.
And that's this triangle right here.
9.
And the way I know that that's the base is because this is the height, and it's perpendicular to that height.
And it's an equilateral triangle. Every single side.
Oh, that's nice. Okay.
That does make it nice. Oh,
So we
my
have-
goodness.
The base is 9, and the height is 7.8.
Oh, wait.
7.8.
Yeah, never mind.
The perimeter is 9 times 3, which is 18.
9 times 3 is not 18.
No, I'm sorry. It's 27.
I want to make sure.
No kidding.
I mean, the formula, this formula is long. And then the slant height.
5.6.
I heard 5.6. Do you know where we got that, Amy?
Yes.
Okay, good. You can just put that right in. It's your calculator.
Wednesday.
Wednesday.
You'll have time?
Hmm?
Wednesday, I have PT at 3:30.
Well, you can
But
work-
Papa won't be here, so I should be able to work.
All right, we got 110.7 centimeters squared.
So it's pretty much the same exact thing as the other
Uh-huh.
lesson. It's just I gotta figure out how to do it.
So
You have to figure out which of the formula for that base. Yes.
I
do we
gotta
need
figure
to
out how to
plug
do it
it?
in
Do we
general.
need